I'd like to take this opportunity to thank Inksol and Hyundu and Chang for inviting me to give a talk here. It's really my great honor to have this chance to share my work with you. I primarily work on biomedical science, and especially neuroscience. And recently, my colleague and I were organizing a project to bring scientists and the philosophers together to work side by side as a team to tackle some newly identified problem. And specifically, we want to identify potential good problem at the intersection between philosophy and AI. So today, the work I share with you is a baby step toward that endeavor. And the talk of today is about developing two types of case study method for analyzing biomedical science. Two of my co-authors are neuroscientists. One is electrophysiology, the other one is computational neuroscientists. So I want to talk a little bit about why we want to do this project. The first motivation is we want to develop some method to help philosopher biomedical science to handle a large body of literature without the help of historical hindsight. Because we're not like people doing history of physics or history of chemistry that they have historian already provide some well-studied historical cases and they can start their philosophical analysis based on those well-researched historical cases. In our field, biomedical science, sometimes you have research start developing within 20 years, you have a huge amount of literature to analyze. And no historian tell us that which one is more respectable. And then even you go to do interview with scientists, sometimes they don't have consensus in the field too. So as a philosopher, we want to identify important philosophical issue happening right now in the field. We need some tools to help. And that's why we want to do this project. The second part is that we want to make philosophy more relevant to scientists. So we think we need to change the way we do philosophy by coming up with some more effective way to convince science to work with us. And you know scientists love quantitative data. So in this project, you're going to see some quantitative data is to, we think using this quantitative data could be a more efficient way to say, hey, we know your field. This data will show you the pattern you don't even know about your field. And we're telling you there's a problem. Let's work together. So that's our strategy. So what we're going to do, we're going to develop two types of method. One is quantitative, the other one is qualitative. For the quantitative part is to develop some quantitative measure to mark or label the target body of literature. The qualitative part is to do what we philosophers are trained to do, what we're good at, is to analyze concept, analyze methods, analyze epistemological issue. But here we're going to give a small tweak here, that we're going to focus on scientific activities. It's a broader category because you know that in biomedical sciences, a lot of research is now constructing like the fundamental physics. So we need to broaden our perspective when we analyze scientific activity. And then just note that these two are complement each other because we want to demonstrate you that the kind of analysis we philosophers used to do can be compatible, can be used together with the quantitative analysis. So our strategy now is we think the best way to show you what our method is to just by showing how to use it. So we're going to articulate the detail of our case study method by showing how to use it to analyze the development of particular biomedical field. And specifically, we'll demonstrate how to use our method to first robustly identify non-transparent patterns regarding a body of literature. And what I mean by robust is that with this kind of method, if you input a certain set of data, you guarantee to get result. It's kind of like computational replicability because it doesn't vary because I input the data or Inksol input the data because it's the same algorithm, so the result is the same. And then it's non-transparent in the sense that you're not easily, or you're probably not going to get this data by reading every paper on your own. And then so, for example, suppose we're talking about 20,000 articles. you could spend all your time reading every paper through. You might get some insight. But the pattern we identify by using our quantitative study is going to be the pattern that's not easy to be identified by reading papers. And second is that we will demonstrate how to generate and refine research questions and hypotheses by using our methods. So the outline today, the session 1, I'm going to show you that what research topic we're going to focus on, which field, period, and the body of literature. Section 2, I'm going to show you the quantitative part. Section 3, I'm going to show you the qualitative part. And in section 4, we're going to show you how to generate hypotheses based on the result. So let's start with the section 1. The research topic we're going to focus on is the studies on physiological phenomena called heart rate variability and its clinical and non-clinical applications. And this is a typical situation where you do this electrocardiogram where you have electrode placed on your heart to get your signal from your heart. And going to show us a wave on the computer monitor. A typical wave on the electrocardiography is that you have 3 components. The one is P wave, QRS complex, and T. So if you have 2 waves line up together, between these 2 peaks, RR, we call it RR interval. And HRV refers to the variation of this RR interval. So as you can see from the screen that there's 2 peaks, and the distance between the 2 varies as time goes. And they analyze this variation by using some frequency analysis. And then that's what HRV is about. And the many studies have shown its potential in clinical and non-clinical applications, especially as a biomarker for correlation to cardiovascular disease. So we're going to focus on that because it's a recent developed field in the past 30 years, and then there's a huge amount of literature comes out just by searching this keyword. So right now, what we're going to do is going to perform some quantitative analysis on this field. So we use the database called Web of Science, and we searched year from 1970 to 2016 using keyword heart rate variability. And then our selection criterion is determined by a process of trial and error because the goal is that we don't want to have articles that only be cited for a few times. And then we want to exclude out this only cited few times article. And then so by trial and error, we then settle in with this criterion. Using this criterion, and we select 40 articles. 25 are original research article, number as OA1, OA2. 15 are review articles. Among these 40 articles, 1 article we label RA11 has highest citation number. It's cited 6,460 times. So we plot this article against the original research article. You can see the citation of this review article is significantly higher than other original research article. And we also plot it against the other review article. So you can see this RA11 also cited significantly higher than other review articles. And so something interesting happened here. Within the field, this review article plays some role. We don't know yet, but it's significant. So let's take at this moment, we'll stop and then note that we, of course, are aware of the limitation of citation number because everybody, there could be many reasons why a person cite a paper. We cite it doesn't mean you endorse it. You cite could be many different kinds of reasons. But we think it's at least a good starting point for further philosophical analysis because by starting with the citation number and going through the database, you at least screening all the relevant papers in the given database. And then you get some initial pattern that can direct your further analysis. So next section, we're going to do 2 more sets of quantitative analysis to review more information about the development of this field and its relation to this review article. Second set of analysis we do is classification analysis. So we again use keyword, and then this time we collect 19,795 articles published between this time, and then draw from PubMed database. So we classify all these articles into one of three categories by an HRV expert manually. So the three articles are, the first one is, the research is about foundational research on relevant mechanism or technological advances. Second category is correlation to cardiovascular disease. Category C is correlation to non-cardiovascular disease. So then we plug all the paper in this diagram. This is how you read a diagram. This we put 1,000 article. Every column means 1,000 article, and then we arrange them chronologically. And this part shows that indicate the percentage of each type of research within this 1,000 article. So here you can see that within this 1,000 article, type A, which is foundational research, counts at roughly like 22-23%, and type B is 27%, and so on. And so if we cut it at the year where this review article is published, which is 1996, and you can see that this is a good point where the type C research going down and go up. So if you also cut here, you can see the pattern of change going down, going up, and then stay up stably. Likewise, for the type B and type A, you see them they changing, but after 96, they going down in a consistent manner. So after 2001, type C research consistently maintained above 60%. Type B are roughly about 15 to 20%, and the type A is always under the 50%. So we performed another set of analysis called text analysis. And the goal is to analyze the article titles of those articles we just analyzed in second set of data. And we focus on the title because we want to know what the topic of this paper is about. We only want to know the topic. We at the moment we are not focusing on what the claim it makes. We only focus on the topic. And the purpose here is to identify how research topics evolve between this time. And why do we want to do this additional set of analysis? Because we want to provide some independent way of confirming the results of the classification analysis. So in the following diagram, I'm going to show you, we plot the 5 most frequent words in every 10,000 article based on analyzing the only article title. And the visualization I'm going to show you, the text size reflect the absolute occurrence frequency of each word. So this is the quantitative data, and we'll visualize that in terms of the following, and plot and visualize in a way similar to the figure you see in the second set. It's also 1,000 paper arranged chronologically. Within this 1,000 paper, this 5 word, the frequency is highest. And so we also cut it as we cut it in the second figure, where 96 is the review article published, 2001 where the pattern stopped, after shifting start getting stabilized. And then you can see that all these mark the topic, exercise, sleep, or stress are all belong to type C research. That's non-clinical, non-cardiovascular related clinical application. And so you see that they rapidly increase after 2001. It's consistent with the pattern we identified in the second set of analysis. So summary of all this quantitative analysis, we get that from the first set, we identified this review article. From the second set, we show you the pattern. And the second set of data just give you more information about the topic, how the research topic evolved, and it's consistent with the second set of data. So based on this quantitative analysis, then we can first identify this, what I call non-transparent pattern. That is, this field has this pattern of change, and it's correlated with this review article, and the review article is most cited in the field. And as a result of that, we can generate a research question based on these 3 sets of data. We can ask, what is the relationship between this article and the quantitative change of the field? And of course, then we want to analyze into it to get more information. Here's where our quantitative analysis comes in. This just to remind you that we have demonstrated you how to use our method to identify the non-transparent pattern, generate research question, and now we're going to move on to how to refine research question and generate hypothesis. So let's move to the section 3. So here we are using what we call a practice-based approach, which is take a scientific practice or scientific activity as a unit of analysis. And we follow Hassel-Chan's characterization of scientific practice as a 3-place relationship where you have scientists and their activities, basically what they do, what they perform in their lab, and their goals, and mostly focus on epistemic goals, but they have goals they also have non-epistemic goals. But in general, this is the framework we use. And I call it frameworks because you need to, when you read scientific papers, there's so many information in there. As a philosopher, you could say, oh, I'm going to focus on what theoretical model you defend. But I can also focus on what activities you perform to analyze the data so that you can avoid reproducibility crisis, this kind of thing. So then if you take this framework, then you start looking about who is performing the activity, what kind of activity. Are they aiming for predicting something or satisfy some statistical task, or they are just exploring space of possibility? You need to fix all these elements to perform your analysis. So what we do is that the steps we use for our practice-based qualitative analysis, that we identify the goals that the task force, which is a group of scientists, published that the review article, what their goals and what activity they perform in order to achieve these goals. And for our purpose at this stage, we want to analyze what they accomplished in those 2 years and how those accomplishments related to the subsequent pattern of change as we have identified through our quantitative analysis. And we want to know that we can generate this question and these 2 goals for qualitative analysis because we have this quantitative data to guide us. So this is what we want to show you, that how the 2 can work together. So in the interest of time, I cannot go through all the details, but I want to just give you some quantitative data to show you that what their major achievement is for this, what the major achievement of this task force. So they specify 5 goals they want to achieve. They want to standardize this various terms. They want to specify the standard method for measurement. They want to define correlates, describe appropriate clinical application, and identify areas for future research. So if you kind of analyze, you can see that specify standard methods and then standardized term, define correlate, describe it, appropriate acceptable clinical application can all seen as related to, like, can be put under the same category as they want to standardize things, make it more you have a common currency, consistent standard for the field. And so we lumped all this together, and then this data shows that if you exclude reference, this paper is 22 pages. 10 pages devoted to doing this thing, 3 pages devoted to doing this thing, and 5 pages devoted to doing this thing. And if you add up them together, they constitute 87% of the published paper. And the identified area of research has 2 pages, counts 9%. And in there, they specifically emphasize the application in sleep and exercise. and this counts 9%. So, and then in the paper, I go into more detail to show what they do for each things. But the nutshell is that they're not settling theoretical controversy or providing a unified theory or unified model to unify the field. They're doing a lot of standardization work. So here we want to conclude that the standardization is actually the core achievement of this review article. So at this point, we have two facts at our hand. First, from our quantitative method, that you have this pattern chain, you have this review article has its correlation to the pattern. And from our second fact is that the core achievement of this review article is standardization. So then you can then formulate a more refined question to ask, how do we understand the relationship between the two? You have standardization achievement and this pattern change. So this reminds you that at this point, we'll show you how to refine research question. And now we're going to take one more step forward to show you how you can generate hypotheses. Again, utilize what we philosophers of science are good at, we train to do. So here, I want to introduce this concept of exemplar, originally proposed by Kuhn, but then expanded and re-articulated by Roos and Shan to propose a hypothesis regarding the relationship between these two. And we can skip that. And disclaimer first that we do not aim to define the whole package of Kuhn's because we don't want to be Kuhn scholar here. We just want to use this concept happened to be originally articulated by Kuhn, but then there's a more updated version. We think updated version and fits for our purpose here, so we're going to use it. And we're going to cut right into Roos' way of articulating exemplar. So according to Roos, he thinks exemplar are exemplary ways of conceptualizing and intervening in a particular situation. So he gives you some example. For example, you know how to apply concept to a specific situation, but by learning, by mastering this exemplar, then you know how to apply concept to a specific situation. You know how to deploy mathematical tools, apply them correctly to the situation at hand, knowing their limitations and knowing ways to circumvent those limitations. And you know how to conducting instrumental and experimental techniques and procedure, and you recognize significant opportunity to extend the skills to new situation that can extend the research potential of an exemplar. So we think we can subsume the standardization achievement of the task force under the concept of exemplar. So standardized practice establishes exemplary ways of conceptualizing, recording, measuring, analyzing, intervening, and applying. And the standardized practice in the HRV field also provides a common currency for formulating well-defined research problem with relatively standardized way of investigating, and then the field become more the practice of the field become more has its own more coherent structure that is directed or guided by exemplar. So by using this concept, we can formulate exemplar-based hypothesis regarding the question we raised. So we can hypothesize that an exemplar was established by the task force that published this review article. And the review article bears the identified relationship to the changes of the HRV field because it plays a role of exemplar for the field. And noted that this is an empirical claim. And we, of course, you can then reapply the method we propose in a more refined way to further testing this hypothesis. So then you get into this reiterative fashion of you have this, you use quantitative, some kind of conceptual qualitative analysis to generate hypothesis, and then you also use the method to test it and refine your hypothesis, and it is iterative fashion to make your hypothesis better and better. But of course, like all the empirical research, there's a limitation to our hypothesis. We want to acknowledge that. So it's reasonable to assume that this target relationship is a complex phenomenon in the sense that it has other dimensions as well. For example, our hypothesis, exemplar-based hypothesis, only focus on a crucial epistemic dimension, but there could be non-epistemic dimension influencing this target relationship as well. So, but we think that at least our hypothesis identified that crucial one, and then it will help your further analysis. So I'm going to show you that, suppose we bring in another concept, also from philosopher science, that focuses more on non-epistemic dimension. We want to introduce this notion from Yang-Ming and Leonani, the concept of research repertoire. Research repertoire is the concept that they focus on not just product, also the skill it takes to produce the product. So for example, if you are specializing some, if you are a comedian and you specialize in some style performing, and the skill required to deliver that performance is just as important as the actual performance itself. And the skill, how you acquire skill, involves some, could be institutional, material, social, to emphasize the non-epistemic condition. So we can use this concept to formulate another hypothesis called repertoire-based hypothesis. So this review article bears the identified relationship to the change of HIV field because the task force standardized many relevant practice, i.e. played the role of exemplar, and used them to establish a research repertoire in virtue of the administrative, material, technological, and institutional, social, or other relevant roles in play in the HIV field. Of course, this hypothesis is very big and rough, so it needs to be refined because you cannot study all these conditions at the same time. You need to refine it. But we want to just demo that this is how you can also take care of the non-epistemic, more social and other kind of dimension. And then our method can help you do this set of analysis too. You just need to focus more on the affiliation of the author, their geographical location, and then their funding situation, those kind of things. And you can also you can do quantitative analysis with all this information. So we use our method to now at this point we demonstrate how to generate and refine research hypotheses. So now here comes to the methodological conclusion. We want to conclude that we have developed this method to select, justify, and analyze a case study in the ongoing biomedical research field. I want to summarize our methodological advantages that the quantitative part gives you a robust result, and it helps you discover non-transparent patterns in the body of literature. And third, it demonstrates how philosophical analysis of scientific practice, including concepts, are complementary to quantitative analysis. And then it can also help generate research questions and or hypotheses that philosophers and biomedical scientists can work on together as a team. And we also want to point out potential for this method, which is something we really want to deliver for our follow-up project. We want to show that this method can generate an understanding of scientific change within a specific community field and historical period as it applies to more case study. So one of the follow-up project we're going to do is to apply this method to psychoneuroimmunology, and then there is one point psychoneuroimmunology intersect with this HIV research. So we would like to use the method to apply to another field and show how they intersect and show how the change, what the pattern of change involving these two big area of research. And we also think that you can provide insights about future scientific trends in the field because you can, using some quantitative method to show that where most of the publications are all about, and then see how they cluster together. And then, but at the same time, you might see some small module in another topic, and then you kind of have some other way to show that this one is booming and might take over this major one. Then you can use this kind of thing to make a prediction about what the future trend in this field might be. And also, we think it has the potential to accomplish some normative work for that philosopher of science secretly or openly want to do for science. That is, suppose you using this quantitative method to identify some trends, but you have good philosophical analysis, for example, like Professor Tetsushi's analysis about reproducibility crisis. You can really, nail it about the methodological issue, this emerging trend. Then you can send out very comfortably to say, I, as a philosopher of science, am giving warning to this field that if you pursue this trend, you're making a big mistake. There are some really serious methodological problem or epistemic problem in this trend, and you can stop it before it happens. That's how I envision a possible normative role I can play as a philosopher of biomedical science, and don't feel confident about it to stay in front of scientists. So, thank you.
And now we have time to raise questions. Questions you can raise. Yes.
Most of your earlier studies about qualitative and quantitative analysis are pretty impressive, but I'm going to play devil's advocate, okay, and raise the following objection. So, suppose that someone approaches this field from an internal point of view. He traces articles, where all these articles come from, and where the problems derive from. He follows the references, and it all converges to that article, RA11. So you can just bypass your quantitative and qualitative parts and arrive at exactly the same conclusion. So what is the problem with this kind of approach? In other words, what your research can do? What are the things that your research can do that this type of approach cannot do? Make sense?
Yeah, okay. So let me make sure I get that part right. Just you say this person just read the article and trace the reference and get to this review article, and you think this person can also infer that this article, but this tracing thing can say this article is important because I trace references and then they all cite this paper, right? Okay. And then your question is that, so someone doing this, is there anything, okay. So the question is, my quantitative analysis versus this way of doing, are they equally, is there anything quantitative analysis can do, but this one cannot do? That's your question. Yeah. So, very good question. And let me show you the, oops. I think it comes in different, so first of all, like I start with, we want to say, hey, scientists, listen to me. And then you can do your tracing tree. As I imagine the strongest one, like this tracing really involves a lot of literature. So one crucial question is that in our quantitative analysis, we cover all the paper we can search from database. And then so it's almost 20,000 articles. So I imagine one person doing this tracing tree, that's estimate that I give it the most charitable estimate, suppose it's 2,000. Okay, can you accept that 2,000? And the scale is still big. Like this, like 2,000 paper is only one tenth of this 20,000 scale. And of course, you might get the similar pattern, but in terms of power of persuasion to scientists or to other people, it's like this sense better. Like you can show that we screen all of it. Plus, tracing reference tree only does the job for these citation analysis, like this one. But let's compare with citation analysis. So the citation analysis, there's a lot of interesting part we can zoom in after having this result. So one of the project we are doing it right now is that, so you see there's actually there's highly cited original research article and highly cited review article. So we want to do inter-comparison with the more detailed, close reading to analyze what happened between us, why at the end, epistemologically speaking, why this review article comes out, what's the difference there? And this will show this kind of directing power by having this quantitative data rather than just, you read and trace the reference on your own. Another thing is that tracing only cover the citation analysis, it only a counterpart of the citation analysis, but we also have this classification and this kind of text analysis article. It also gives you more information and then can direct you to look into some more interesting part and zoom in. For example, we also want to look at all the article published after 2001, and this Type C article, and we want to analyze how Type C article cite review article. Who cited just by literature review, and who cited really at the method section where they're following the method suggested by review article. And then if the method section cites more, that gives more evidence to support our exemplar-based hypothesis. And so this kind of thing really gives you more information to help you formulate your next step research. And so that's why we see the quantitative and the power of quantitative analysis.
Okay.
Any more questions there? Okay.
Yeah, thank you so much for your great talk. I really enjoyed it. So, I felt that you did really hard and difficult work. So my question is that, when I hearing your talk, I thought that, for example, except the text analysis part, it seems like you, for example, for classifying more than 10,000 articles, you didn't use natural language processing techniques. And if you use natural language processing technique, then you needed to learn some basic parts of the natural language processing techniques, and very effectively communicate with the computer experts. So my question is that learning some different disciplines or communicating with the people with different disciplines need much more energy. So my question is that, so do you think that this kind of interdisciplinary approach is more efficient or promising than when comparing with previous traditional approaches? And if you think yes, I want to hear why you think so.
Yeah, that's a great question. So let me get to the text analysis part first. So I need to, so before I conduct this research, I don't know how to do text analysis at all, and I still don't. And that's the beauty of having an expert as a team work side by side. Because, it's hard enough to learn philosophy to our, this, to be professional level. It's a serious work. It's not something you can just pick up overnight. And we need to respect our own expertise as well. And then, of course, if you're really, really smart, I'm not one of them. I cannot just learn the technique and do it yourself. I do think I want to keep refine my philosophical skill, but applying to scientific field. And then those technical part, just let who good at that to do that. And then the main key point is that you really work as a team together. And then I also find my philosophical training is very useful when I need to pick up their analysis to understand it in a general level and know how to bear it with the philosophical analysis I'm going to do. And so I think it takes some energy to learn the basics of test analysis, but it's not consume some, at least for me personally, consume some energy, but it's not very difficult. But of course, it's very difficult if you ask me to perform this quantitative analysis on my own, to learn the technique, to learn the modeling. We actually do more than this. We also do topic modeling, but the data is not good, so we didn't show. And so all these things performed by my co-author. They know what we know our question, know our project, know what we want to do, and then he performed this part, and we do the other part. And so then back to your second question, this compared to a traditional analysis, I still love traditional philosophy stuff, but I think interdisciplinary research is, for one thing, a lot of questions I care is too complex that as I do more traditional analysis, I see it's an efficiency, not that it's bad. It could do very well, but you still see that it's still insufficient to really solve a more complex problem. So for me, it's not out of disrespecting traditional philosophy of science. It's more like how we can, take the best part out of it, and that it evolved together with the best part of science, not pseudoscience. and I think if you are students and you have teacher around you just doing this, then you will just learn by example, and this thing will seem natural to you. So I hope that you as a student or young scholars, you still have chance to shape your research this way. I started to do this research when I start working as a professor. So it's new and it's doable. And if you have a professor doing this and you work with that professor, then you would just naturally pick up. It's like learning a skill and naturally for you. And so I think if you like this kind of research, you can start it early, and then it's actually not that difficult for you. Hope that answers your questions.
Great. Yeah. That's a final question.
Thank you for the presentation. I have two short questions. One question is about I wonder whether you guys have in mind the mixed method approaches that overarch the most remnants of quantitative and qualitative method. So, as far as I know, the mixed method approach takes the advantages of both approaches. And my second question is, did you guys use any computing tools when you classify the more than 20,000 articles? In your article, you mentioned you manually classified, but I just wonder.
Yeah. So for the second question, no, we do it manually. Can you say again your first question? I'm not sure I get it.
I'm not a professional in this kind of field, but I heard that there's an approach that overarches, combines the quantitative and qualitative method, which is called the mixed method.
The mixed method, okay. Yeah, I'm new to that term as well. I'm only familiar with digital humanities. They doing this kind of they do a lot of test analysis and other things as well. And then for the classification part, the reason we end up doing manually because our topic modeling data is not good, and so one of my colleagues decided I'm just going to do it manually. Originally, we hoped that topic modeling can take care of this part, take care of the classification part, but it doesn't work. So then he really wanted to do it, so he do it manually, which is very demanding job to do that. What he does is he read the article and the article abstract and to determine whether it falls into one of the category. And if the information is not insufficient, then he go to read the article. And the thing is that he's been in this field for all his career, so many papers he's already familiar with, and type of research he's also very familiar with him. So he can spend less time than normal people, but still takes a lot of time. I think he spent 4 to 5 months to complete this classification.
Okay, that is the end of the lecture. Let's give a big hand to Professor Yang.